Okay, in this class, you will have to solve a couple of differential equations, but all of the equations take the form as shown in the black, where C is a constant. In this particular example, I'm going to show you how to solve an equation when F is also a constant. These are called constant coefficient linear differential equations. In order to find the solution to the black equation, what we'll do is we'll find the solutions to the red equation, where you take the constant F term and set it equal to 0. Your differential equations class will give you some theory as to why that is. Engineers call this a transient solution. As you'll see, it only hangs around for a little while. That's why it's called transient. And then after finding the red solution, then we'll go back in and find the actual solution for the blue. We add the red solution and the blue solution together to get the complete solution. Okay, so let's begin with the red. Basically, for all of the equations, and they will all in this class look like the red equation. You can manipulate it until it does. Okay, so what you do is you guess at the solution. The guess is always the same thing. So, it's really not a guess, but at this point, with the theory that you just say, hey, I'm guessing. Okay, so what we're going to do is we're going to guess that the answer is a constant, e to a power times t. Now, to prove that the guess is correct, what you do is you take a derivative of this, which isn't too hard. So what we do is we just take a derivative. And now what you do is you take these two values and you put it into the original red equation. So you have y dot, that's a p e to the pt, plus a constant c times y is equal to a e to the pt equals 0. Now at this point, what you realize is that there's a common factor of e to the pt. That is never 0, so you can divide through by it. You also see that there's a constant or a common term a, so you can divide by a as long as a is not 0. So you divide that, and what you're left with is p plus c equals 0. Now you're trying to prove that this is correct, and so as long as you can satisfy this equation, it will be a solution. So the solution is going to be p equals minus c. All right, so what does that tell me? Well, I'm going to put that into my guess. So it says that y is equal to a constant, e to the minus c t. So that's the solution to the red equation. Now, a is a constant that I don't know what it is yet, but it can be anything, because if you notice it factored out. It doesn't matter what a is. This will be a solution to the red equation. Turns out that what a is it's the values at the initial condition. So just like when you integrate something, you always have this arbitrary constant. That's what the a term is. That's your arbitrary constant that allows you to adjust the initial condition. Okay, so that's the solution to a. Now to find the blue solution, what I'm going to do is also guess. So what I'll do is I'll say, well, if the blue equation is going to be true and f is a constant, one of the easiest things to do is to say, well, I think that the value of y is going to be a constant as well. Well, let's see if that's true. Okay, so for the blue, I'm going to say, all right, I believe that y is equal to a constant. Let's just call it k. I don't know what constant, but I'm just guessing. Okay, so I'm going to do the same thing that I did with the red. I'm going to take a derivative. So the derivative of a constant is equal to 0. All right, so now I'm going to take these two guesses and I'm going to put it into the blue equation, and here's what I get. I get 0 plus c times y is equal to a constant k, is equal to a constant f. Well, this will be true if I can find a k that will make this true. Well, I can. K will equal f divided by c. Okay, so the correct, or the total solution to this is when you take the y value, the red solution, and you add the blue. Okay, so y will equal, the red solution is a e to the minus ct plus k, which is f over c. So that's the complete solution. Now, the only thing that's remaining is, how do you find the number a? Well, you'll have some initial condition. So, for example, if y is equal to, let's say, 3 at a time, it doesn't have to be time equals 0, but a lot of times you'll know the initial, which would be at time equals 0. So you have a value of the output or the solution at a particular time. Okay, so you take that and put it in. So y is equal to 3 a e to the, and then time is equal to 0. So this is e to the 0. E to the 0 is 1. Punch it in on your calculator, right? Plus f over c. So what is a? Well, a is equal to 3 minus f over c. So now the complete solution then, now that you've got your initial condition, y equals a, well, that's equal to 3 minus f over c e to the minus ct plus f over c. That's your complete solution. Okay, that's a lot of steps, and the steps are always going to be the same thing. You're going to do exactly the same thing every time. So really what you want to do is cut out all of the middle steps. So what you want to try and do is cut out all of this stuff right here. Okay, so the easiest way to do that is to realize that when you take your guess at y and you take a derivative of it, it will always come out like this. Wherever you see a dot, you're going to put in a value of p. So you put in p for the y. Okay, so p plus c is equal to 0, right? And if you notice, that's exactly what you ended up with after all of the steps, right? So remember, it's y dot. Instead of dot, you put in p. That's the power of the exponent. Plus c, the y disappears. All you're doing is just skipping all of these steps. And then you can solve for p. P is equal to minus c. Same thing that you had before. So the red solution is y equals a, it's always an arbitrary constant, e to the negative ct. So you can eliminate a lot of these steps. Okay, now the way you get the blue is basically the same thing. What you're going to do is you're going to say, all right, y is equal to a constant. Take a derivative of that, right? So basically what you're going to do is you're going to say, if the y is a constant, then this term right here is 0. So what you're left with is c times a constant equals f, and then you can solve for that constant. Okay, so then, basically what you would do is you'd say, here's my guess, and then you just plug in and get rid of the y dot, okay? And then you put them together. and then you do your initial condition just like before. So you can skip several steps in here until you get good at skipping the steps. You might, for homework, you might just put in all the steps and just, train yourself to be able to do it with the shortcut. Okay, that's it.